All right, ladies and gentlemen, today we're going to walk through our book of exponent rules, so make sure you get yours out. The ones we created yesterday. If you weren't here, make sure you grab one of the extra booklets up front. Go ahead and fill in the front. It should have your name, and then it should say Book of Exponent Rules. These are going to be our laws of exponents. You're going to get real familiar with them. This book is going to help you get through the practice that's about to be handed out as well. So go ahead and get your title filled out, and then open it up to page 1 and 2. Page 1 and 2 is going to read, what is an exponent? Remember, we talked about this yesterday. If I have 2 raised to the third power, or 2 cubed, what does that mean? Well, the 2 is my base, and the 3 is my exponent. So I can expand that as 2 times 2 times 2, which if I do 2 times 2 is 4, and 4 times 2 is 8. So that equals 8. So down at the bottom, the exponent tells us how many times the base is multiplied together or by itself. So we have a base of 2 and an exponent of 3. So that tells us the 2 is multiplied by itself for a total of 3 times. On the right side, if a constant or variable does not have a written exponent, it is automatically an exponent of 1. For example, 6 is 6 to the first, a is a to the first, and x, y squared z is x to the first times y squared times z to the first. So I'll give you a second to get those down. All right, a couple examples that we're going to walk through. We're just practicing expanding out a base and an exponent. We talked about this yesterday a little bit. All right, so if I have 3 squared, that is the same thing as 3 times 3, which we should all know equals 9. On the bottom, I have a squared times b cubed. Well, a squared tells me my base of a is multiplied twice, times b cubed tells me my base of b is multiplied 3 times. So times b times b times b. Alright, I'm sorry on that middle b, you can't see it. Alright, but that's just expanding exponents. Next, we're going to flip over to page 3 and 4. Make sure you can follow along. If at any point you get lost, feel free to ask your partner what the blanks are supposed to be. So up top it says, remember you only use these exponent rules with like bases. If I don't have like bases, then the same rules do not apply. Alright, so on the left side, right up top, we start talking power of a power. So our rule there is going to be a raised to the m power, in parentheses, raised to the n power equals a raised to the m times n. So I know when it's nothing but variables, it makes it a little confusing. So if we look at our example there, 7 raised to the third, raised to the second, I take that 3 and that 2 and I multiply them together. My base is not going to change, so I get 7 raised to the sixth. On the example below it, we have x raised to the fourth, again raised to the fourth, which gives me 4 times 4 is 16, so x raised to the 16th. Notice that on both of those problems, my base did not change. Below that, on product of powers, we have a raised to the m times a raised to the n, which equals a raised to the m plus n. So now, again, my base isn't going to change, but when I'm multiplying bases together and they have different exponents, I simply add their exponents together. So my first example, 3 raised to the fifth times 3 raised to the fourth equals 3 raised to the ninth, because 5 plus 4 is 9. It doesn't change if I have a variable at the bottom. Q raised to the fourth times q raised to the seventh equals q raised to the 11th, because 7 plus 4 is 11. Alright, so if we look at the 2 examples I have written down below, our first example is 2 raised to the fourth raised to the second, or squared. Alright, so if I were to expand that out, it would be 2 raised to the 4th 2 times, which would multiply 2 raised to the 4th. And now, that looks exactly like the problem below it, so we'll handle them at the same time. 4 raised to the 3rd times 4 squared is now a product of a power. And so if we follow our rule there, we take the exponent and add it, but the base stays the same. So here our base is still 4. 3 plus 2 gives us 5. So that would be our final answer there. And then up top, 2 raised to the 4th times 2 raised to the 4th, sorry about the light, would give us 2 raised to the 4 plus 4, which is 8. And notice we accomplished the same thing here. If we just take our 4 and multiply it by our 2, it gives us our exponent of 8. On the right side, if we look, when dividing with like bases, remember all of this has to be done with like bases, pretend the division bar, which is also called the vinculum, you never know when that could be an extra credit question, pretend the division bar is like a giant subtraction sign. That rule is going to be our quotient of powers. Alright, so if I look at it, I have a raised to the m power divided by a raised to the n power gives me a raised to the m minus n power. So you just take the exponents, subtract them, and the base stays the same. So our first example we're going to look at down here, 8 raised to the 8th power divided by 8 raised to the 6th power. 8 minus 6 is 2, so I get 8 raised to the 2nd power, or 8 squared. Same rules apply if I have a variable, as long as my bases are the same. H raised to the 3rd power, or h cubed, divided by h to the 5th power. 3 minus 5 this time gives me a negative 2, which will leave me with h raised to the negative 2 power. Alright, so if we look at a couple of these examples off to the side, we're just practicing our quotient of powers rule. So I have g cubed divided by g squared. So all I'm going to do, my base of g is going to remain. But then I take my exponents, 3 minus 2, which leaves me with an exponent of 1. But if you remember from the page before, anything raised to the 1st power is just itself. So my final answer there would be g. On the next problem down, I try and make it a little more complicated. But what you have to remember is you can only apply these laws to the like bases. So x to the 4th y cubed divided by x squared times y. The x's are going to stay together, so the base of x is going to stay out here. And the base of y is going to stay together, so I'm going to have a y out here. But what we have to now do is work with the exponents. So my exponent up top of 4 minus my exponent on bottom of 2. 4 minus 2 leaves me 2. So my exponent with the x will be a 2. And my exponent with y up top is 3. Notice how there's not an exponent written with the y down here. The same rule applies, so it's automatically a 1. So 3 minus 1 will leave me a 2, so I'm also going to be left with y squared. And that would be your final answer there. All right, next up on page 5, we have our negative exponents rule. All right, so to turn a negative exponent into a positive exponent, we're going to remember the phrase cross the line and change the sign of the exponent. Cross the line and change the sign of the exponent. The line we're talking about is going to be that vinculum or the division bar. So let's look at our rule. A raised to the negative n equals 1 over a to the positive n. So notice the n doesn't change, but if it's in the numerator of a fraction or doesn't have a fraction, it then becomes in the denominator. And that same rule would apply if it's already in the denominator. So we're just going to cross the fraction sign, and the sign of the exponent is going to change. So let's look at our first example that we already have written in our journal or our notes. X raised to the negative 3rd divided by g raised to the negative 4th Notice how both of those exponents are negative. So each one of them has to cross the line, and then change the sign. So the g to the negative fourth is going to go up top, and the exponent's going to become a positive 4. The x to the negative third is going to go to the bottom, and the exponent's going to become a positive third, and you're left with g to the fourth divided by x to the third. Same thing applies on the example on the right. 4 raised to the negative 2 is the same thing as 1 over 4 to the positive 2. Again, notice the value of n did not change, only the sign changes. Alright, so if we look at a couple examples of what to do with a negative exponent, alright, we're going to go ahead and look at the first example, x raised to the negative 2. Again, the value of that exponent is not going to change. It just needs to cross the line. Now, currently, there's no line for it to cross, so I have to create one. The x to the negative 2 goes to the bottom and becomes a positive 2, and something has to occupy the numerator of that fraction, so that's where we enter our 1. If we look at the second example, g to the fourth times x to the negative third, only one of those exponents is negative, so only that base and exponent will go to the bottom. So g to the fourth will remain up top. X to the negative third will go to the bottom and become x to the positive third. And notice we don't have to put a 1 because there is something occupying the numerator. Now, there is a chance that the negative exponent will already be in the denominator. So, for instance, if we have 3 divided by t to the negative fourth, in order to make that negative 4 exponent a positive 4, we have to cross the line. So we don't only go down, we can also go back up. So this would become 3 times t to the positive fourth. Next up on page 6, this is going to be your favorite page. Our zero power rule simply states that anything raised to the 0 power is equal to 1. So the way the law is going to be written is a raised to the 0 power equals 1. No matter how complicated the exponent gets or the base gets, if it's raised to the 0 power, it equals 1. So our two examples we're going to look at is 7 raised to the 0 power. Again, anything raised to the 0 power equals 1. If we look over here, we have in parentheses x squared y cubed z to the fourth, close parentheses, all of that raised to the 0 power, again, just equals 1. Alright, so if we look at this one example, x squared times y to the 0 times t to the fourth. Notice, there's no other base with the x, so the x squared is going to end up staying. There's no other base with the y, but anything to the 0 equals 1, so this would just be times 1. And then there's no other base to match up with the t, so the t to the fourth would stay, so times t to the fourth. Now in there's one piece of information that doesn't need to be written, and that would be the 1. So our final answer here would just be x squared t to the fourth. Alright, and that wraps up our laws of exponents foldable. This foldable now can be used to finish the practice problems that you have in front of you. We'll also use it next week as we continue laws of exponents. Make sure if you have any questions, any comments or concerns, you're writing them down so that when we return you can ask them. Thank you.